This video covers some additional topics related to looping. Specifically, we'll discuss list comprehension, some nested looping concepts, two built-in iteration functions, enumerate and zip, and finally os.walk. Sometimes you have a list of things and you want to do exactly the same thing to everything in the list. What will happen when you're working on your project? Say you have the set of field object. You've done a list fields. That returns a list of field objects. But what you really want is the list of field names, because you want to do something with those names. In that case, you want to do the same thing to every field object. You want to dot name it. And what you want is to get back a list that has just the names instead of the field object. Then you can use something called list comprehension. So list comprehension is a Python shortcut that's optimized to be faster than looping. It's a bit like looping, but it's really very specific for taking an existing list, doing some same change to everything in the list, and returning a new list with the changes in it. When you think of the word comprehension, you usually think of understanding something. In this use of the word, it has to do with the sense of comprising of a set of things, being made up of a set of things. You have a set of file paths. You want to get a list of file names. So you would want to do that os.path.base name to every single one of them. Or if you have a list of strings that are field names from some CSV file, or some of the fields have spaces within them, and ArcGIS isn't going to handle that when you try to import it, so you want to replace every one of the spaces with underscore. So these are the kinds of things that you can do with list comprehension. First, look at the naive way to do changes to everything in the list, and then we'll work up to list comprehension. Suppose we want to make a list that is the first initials of every item in list A. So we want a list that'll be FSCR. The way you would usually, well, the way with what we're equipped with, if you don't know about list comprehension yet, you would say, okay, I've got a list. I need to make a new list, an empty list, and then I can append things to it. In this loop, I'm saying for item in A, so A is going to have FID, then shape, then cover, then item is going to become FID, shape, cover, and recno. It's going to loop through and point to each of those in turn. And what is this line doing? Indexing into the first position of items. The first time we go through this loop, what is temp going to be? F. That's the letter F. Item will be FID, and we're going to get the first letter in that. So that'll be F. And what does this statement do? Yeah, it adds F to the end of list. It doesn't have anything in it yet, so it'll be the first item in it. And then when we loop around again, what's going to happen? Temp will become S, because item is shape. And it's going to, what will the list be after we do this step in the second loop? FS. So in the end, it'll be FSCR after it steps through there 4 times. So that'll be the output. We're making an empty list, B. We're looping over each item in list A for each item in A. We're deriving some value. In this case, it's the first letter of each item in A. So we're deriving that value, and then we're appending the derived value from B. Here's an example which does the same thing as the previous slide. Can you write the code that'll do the same thing, except the task this time is to find the length of each string in X. So X is the same thing as A was on the first slide. It's that list of field names. Code's going to look very much like the example that's above, but it's going to be slightly different because you're finding the length of each string. Yeah, it's good, except for and this looks like a capital F to me. Is that a capital F? And it also looks like it's indented too far because it should be lined up with this one, right? Pause the video now to try it yourself. Okay, no syntax errors, but there's one thing that's going to be a little different, which is how many, so when you print Z, what's it going to have? Yeah, the first time. Right, it's inside of your loop. So it's going to have one thing the first time, two things the second. It'll print out 4 times as it adds things. So this guy, len, is a built-in function. So you don't put a object dot in front of it. So you can take that out and set your temp equal to the len of, what is that symbol there? Scribble. The len of scribble. Think of it word, okay, n. So where would n go then? You want a temp to be equal to the length of n, right? No dot. It's just a built-in function, so you can say len n. Your output should be 3555. And you got to set up your output list in the first place, or your empty list to put things into, because you can't append to something that hasn't been created yet. And then you find the length. We want to find the length of each of these guys. So use len function, and then the same step as we did above, we're appending it to our list, and then if we print our list out, we get this. That's a lot of code, kind of clunky. There's a faster and more efficient, optimized way to do it. If your expression isn't really complicated, it's nice to use a list comprehension to do this problem. In the list comprehension, the expression comes first. So it's just one of those things where you just got to accept it. And then you put, almost like a for loop, you put for and in with whatever your looping variable is between there. And then you put your original list after that. And you put square braces around the whole thing, and it's going to give you a list. For our example that we're doing with looping and appending, it would look, if we wanted to say, make an all caps version of the items in X, we would do I.upper, right, and then append it. So for list comprehension, our expression would be the thing that we're setting temp equal to. That would go right in the front, and then for whatever our iterating variable is in our original loop. Put square braces around the whole thing and use an assignment statement to give the return value to y. And if we do that, y is equal to same thing as we have over here. All in one nice little tidy line of code. Here's an expression that uses I. Whatever your iterating variable is named, in this case I, it should always use that somewhere, because it means that you're doing something to the original list and changing it. What does y look like for this example? Write it down. Insensitive. Yeah, a good way to check if, like, so that was the one where you were checking if out was in the variable. So a good way to check if, in case insensitively, if something is in there, is to lowercase it. Like take whatever the whole word is, lowercase it, and then compare it to the lowercase version of the thing that you're looking for. Good.
I wasn't sure.
It sounds like you were successful.
Thing that you just put in.
Oh, there probably is, but that's a simple way to do it.
Okay.
How about this one? This is more like a test of remembering all the string methods. There's a string method for replacement. It's a good one to have at your fingertips because it's pretty useful a lot of the time. Yes, except for replace is a function. So these guys should be, yeah. You would have gotten a syntax error if you tried that in your browser. Something like that. And your output will look like that. Here's one to try with your neighbor. If any of you are into jazz, which I'm not particularly, but I think scats are kind of cool. This is a scat script to help us warm up because we're going to do some nested looping. Question here is, what does this script print out? Try to read it to your neighbor. Just pair up with someone and try to read out skip D and then some stuff. So it's an outer loop with a range of 2, an inner loop with a range of 3. Try it. Come on, don't be shy. Yeah. Wanna walk like you, talk like you. Skitty beep beep. Bop bop bop. Put up? Is it skitty beep beep? Or is it skitty beep? Bop bop bop. skitty, beep. We get to here, we get to line 4, and we beep. And then we go here, right? So, start over. Pause the video now to try it yourself. Because this one is looping how many times, the inner loop? Yeah. So you say j becomes 0, and you bop. J becomes 1, and you bop. J becomes 2, and you bop. And then you're at the end of this loop, so you go back up, and I becomes 1. Beep. Bop, bop, bop. Okay, so can you do it all over again?
Beep. For eat, beep. Bop, bop, bop. Beep, bop, bop, bop.
Yep. So did you get it? It's going to print number 2 once, and then it's going to go to line 3, and I'll become 0, right? So it goes beep. And then it's going to go to line 5, and J is going to become 0. So it's going to go bop. Then J becomes 1, the inner loop, 1. So bop. And then J becomes 2, bop. So how many bops do we have there? We've got 3, and that's it, right? Because that's it. It's going to, the range tree returns what? A list of 0, 1, 2. And then what? After you 3 beeps here, or after 3 bops here, what? You go back up to your outer loop. Because this was 0, and now it's going to become 1. So you're going to go beep, and then bop, bop, bop. And then you go up here. Is it going to go back in again? No, we've gone twice. So, badoop. That's it. So nested loop, it happens sometimes when you need to do hierarchical structures, like get the pricing value of each building on each parcel of land. The hierarchy here is that there are parcels that contain buildings. And if you have n parcels and the average number of buildings on a parcel is m, how many times are you going to have to do this? On average. You're going to get the value in n times m. There are n times m values to calculate. So that's one of those things that if you have hierarchical looping, that if n and m are roughly the same, it's going to grow in, just like the parabola, n squared kind of thing. So if you have code that's got nested looping, that may be a point that when you get much bigger data sets, it becomes really slow and takes days and days to process. If you were to write pseudocode for how to print each row of each table in the current directory, if you're looking at tables, what do you probably want to put as the inside loop? You want to put the tables on the inside loop or the rows on the inside loop? Yeah, rows. And this has to actually do with how long it takes to go and get data. So usually when you load a table, when your computer loads a table, it loads that whole table so then it can just sequentially point to each value in the table in memory. As opposed to what you usually have to do when you go out and get a table, you have to go and seek to the disk. And the disk is going around, and the arm that goes over the disk, like probably some of you have never seen a record player, but it's floating over the disk and it's finding the data on the disk. If you were to put the table in on the inside loop, you would be going and opening the table over and over, as opposed to opening it once, getting the stuff in memory, and then pointing to each row. If they're stored sequentially in the memory, then it'll be much faster. So your pseudocode for that might look something like this. To go through numbers like 10, 11, 12, 20, 21, 22, 30, 31, 32, and so forth. Can you see a way to combine these two loops so that it would do that? So this first loop prints the values what? 0, 1, 2. And what is this comma doing? Anybody remember that? If you put a comma at the end of a print statement, after the print statement, it'll make it so that it doesn't do the carriage return. The next thing that prints will be on the same line. So in other words, instead of printing 0 with 1 below it, with 2 below it, it'll print 0, 1, 2 with just a space between them on the same row. So what does this loop print? 10, 20, 30, 40, 50. Right, it doesn't do 60 because that's the way the range function works. Okay. If you were to say, try to do some nested looping, can you think of a way to combine, use these two loops to print out these numbers in this order? Try it. Write it down. And 0 to get 10, and then 10 and 1 to get 11. Pause the video now to try it
do
yourself.
Something like this. Pretty much your solution is going to be, one of the other is going to be on the inside. It doesn't matter which because addition is associative. But if you add the two values together, you're getting this result. 10 plus 0, 10 plus 1, 10 plus 2. And then it'll go up and it'll say x is now 20. And it'll say 20 plus 0, 20 plus 1, 20 plus 2. You look suspicious, like you don't really believe it. Maybe it's one of those things you have to try on your IDE to get it to really understand it. But that's the way you could combine them and get that result. Another thing that is useful to do sometimes, so now we're getting away from, we did list comprehension, we did nested looping, and now we're going to go on to another built-in function, which is called the enumerate function. Like len, like int, like float, like type, it's another built-in function, so there's no dot to use it. You just say enumerate, blah. The idea of the enumerate function is that sometimes you want to use a for loop and you want to have the value of the thing that you're looping through, which is what you always get, but you also want to have that index. You're looping through and you want to know if you're looping the first time or the second time or the third time or so forth. Like which, are you looping, are you at the 0th thing in the list, are you at the first thing in the list, are you at the second thing in the list? That's what this enumerate function allows you to do. So suppose you want to write a function that will print out your arguments from the sys.argv. Always a little bit of confusion when you're trying to figure out what did it take? Did it pass in the right things? Let me just check that and print that out as I'm starting my script. So you could use this enumerate function not only to get the value, but also to get the index. So you know that this was the first one, this was the second one, this is the third one, and so forth. So that's what this function would print out if you loop through sys.argv, which is a Python what? List, yeah, list. And you put this enumerate function around it, then you can put two values in between 4 and n, and you'll get both the index in the list and the value in the list. If we run this script, it says argument 0 equals, that's this print statement, argument 0 equals this. And the index, the 0 is coming from the index variable, and this path is coming from the value variable. So argument 1 equals I. Argument 2 equals love. So forth. So this is the way that you use this is the general format for that, is to, again, loop through sequences, which we're using a list. Okay, so usually it's a list. Just like our regular loop, the list comes at the end. But in this case, you have the enumerate function wrapped around it. And our regular loop only has one iterating variable between 4 and n. In our enumerate loop, there are two things returned, so we need to have two variables in between there. You put them in between there with a comma, and it gives you that as a tuple return. How would you print each index and value of this list using that enumerate function? Your output should look something like this first picture here. 0 and FID, 1 and shape, 2 and cover, 3 and recno. So the question was, do you have to define index or value beforehand? No. It's just like when you have 1 there, you just make up a variable name out of the blue. It's the same thing you're doing. You could have called them foo1 and foo2.
Pause the video now to try it yourself.
Our output didn't actually have the equal sign on the slide, but that's okay. Yeah. Num thing in enumerate x print num thing. Can you do this one? Use os.lister and enumerate to print a numbered list of files in ctemp. Remember os.lister?
Pause the video now to try it yourself.
Okay, good. Does this have quotation marks on it? All files. Okay, good. And thing. And oh, you're doing the format function. So this is, Yeah, it looks good. It looks good. So yeah, I used the commas, but I didn't put spaces in, and then I'll give you the right spacing, or the spacing that's here, that's shown here. So I think everybody got it pretty much, or close. Okay, now on to os.walk. So os.lister does what? It lists the files in your current directory. But what if you want to deal with subdirectories? Is your data always in one directory? No. Sometimes it's dispersed in a subdirectory hierarchy. So what we need is something that'll take care of that. Instead of os.lister, we can use os.walk, which will walk down into your subdirectories. And this is a very, very beautiful cauliflower. And the reason that it's on the slide is because we're talking about recursion. We're talking about recursion. Okay, so if you think about the shape of this cauliflower, like if you set it down on the table, it's actually kind of a pointy cauliflower. If you look closer, you would see that each of these little things is the same shape as the mother cauliflower. Each of these little guys is just a reflection of what the whole thing looks like. And then if you looked even closer, you would see that each of these little things has other little towers on it that look just like the bigger one. And so on and so forth. It keeps going, probably, I don't know, down to a molecular scale, I have no idea. But for what you can see, it keeps going and going and going. So that's the property of recursion. It keeps going the same way as you branch down into the subpart. So this walk function, it's a good one to do after enumerate because the format for it is kind of similar to how you do the enumerate. You have to stick a function here and put your list inside the parentheses as an argument. And instead of 2 variables between 4 and n, you have the 3. You have the root, the directory, and the files. If I say have a directory of pictures, these are some travel pictures that we took. So we have pictures, we have some that are on the top level and in the pics folder, and then we have some directories that we've organized some of the other pictures in below that. And some of those directories have subdirectories with pictures inside of them. If we were to use the os.walk function on this directory, if my dir were set to wherever pics is, so say pics is right under the C drive, it would walk through and eventually print out all of the names of the pictures. It would start here up at cpics. So here is our root directory. So root directory is the place where we start. Initially, it's the place where we start. But this is going to be recursive, so the root directory will change. It'll update as we go. So we start with this, and when we're at the root directory, the folders or the directories that are on that level are Italy and Jerusalem. So Italy and Jerusalem are in our dirs list. And then the pictures that are on that level are Istanbul, Istanbul 2, Marble Road, some other stuff. I haven't drawn them all here. but these are the pictures that are on that level. So you'd get files would be a list of things on that level. So then it would say, okay, it would keep track of these guys that were subdirectories, and then it would start going down into them. So the first subdirectory in the list is Italy. So the next thing is when it goes down, so the first 3 print statements come up there, go around, and then root is updated to be the Italy directory. It's our first subfolder. So are there any directories inside of Italy? Yeah, there's a Venice directory. So the directory list is going to be just going to hold Venice in there. And are there any pictures directly under Italy? Yeah, there's backseat, there's bridge, and there's some other things I haven't drawn. So next, it can say, all right, now my DIRS list holds Venice. So I'm going to go down in there and make that my root. And Venice is going to become the root. And does Venice have any subdirectories? Not according to this picture. Okay, it doesn't have any folders underneath of it. So that's why this becomes an empty list. And the images that are underneath of there are listed in the files list. So you can see that root, DIRS, and files is getting updated and walking through this whole thing. So when you get down to an empty list like this, it goes back up and it checks the other things that it has on the stack. So we started with Italy. The next thing in that list was Jerusalem. So the next thing it goes to is the Jerusalem directory. Looks for subdirectories there, gives you an empty list for that, finds that there are some pictures in there and lists those. So since we've now gone through all of our subdirectories, we're done. So that's just to give you an idea of how it works. It's going to go through all those directories and look at everybody. So how would you use something like this? Well, usually you want to play with those files in the directory. So you've got your root, your DIRS, and your files. These are random meant to indicate what they hold. Usually you want to actually go in and use those files to do something. Say you want to do some kind of geoprocessing on every file in every subdirectory. So you have some clipping you want to do. You want to clip all these files, and they're not flat in a directory. They're distributed over subdirectories. So you can go through your walk, and then in the inner loop, you can go through the files list. And your geoprocessing would go right inside of the inner loop that's looping through those file lists. And that would hit all of them. So the one thing that you want to do when you're using os.walk is sometimes you want to be able to get that full path file name. So if you add the root to your looping variable that's looping through files, that'll give you that full path file name inside of there. Okay, because F only holds the file name and it doesn't have that root. So that could give you a list. So I'm looping through the subdirectories under data, and I've just taken a screenshot of a very small part of that. So suppose we want to do delete on all of the files in the subdirectory, or in the current directory and its subdirectories. Of course, use this at home with caution. But if you wanted to do that, say you've got too much junk in your ctemp, you want to delete it recursively, you might actually want to be doing it selectively. Say if the file has the word output or buffer in it, you might want to just clear your output and keep your original files or something like that. But you could use this os.walk to do that. So you could do os.walk, and then since F, when we loop through this files list, is just the name of the data, we would need to update the workspace right inside of the outer loop to the root. Okay, so your root is going to be, originally it's going to be your top directory, and then it's going to be your next directory. So you want your workspace, since ArcGIS just handles workspace as a current directory, you want your workspace to be updated. Then your arcpy tool will know where to get that F, where that F is.
ArcGIS also has a walk method, and ideally this would be able to be used to even more specific things than you can set with os.walk, because it has these optional parameters specifying the data type, so you could only list a certain subset of the files in your directories that you were interested in. However, the last time it was tested, there were some issues with the case of grid raster input and file geodatabases. It's probably built on os.walk anyway, so you may as well use os.walk and then use list enumeration methods inside of the loops to specify the data types that you want so you can get a subset. In this example, we are using the os.walk, we set the root, and then list rasters so that we only get the raster GIF types. Then we loop through those and delete those files. There's one thing we can learn from the arcpy.da.Walk call up here. They're using keyword arguments, which are different from positional arguments. So almost all of the arcpy calls that we've made to functions have used positional arguments, where in other words, the position that the argument is in tells it which parameter you're meaning to specify with that argument. In the case of keyword arguments, you don't have to worry about order because you are putting the name of the parameter in there and setting it to the value of the argument that you want to pass in. Here's one to try out yourself. The current version uses a conditional statement, if f.endswith.shp, to get all of the shapefiles in the current workspace. But this won't work if you want to find all of the feature classes that are in your sub workspaces. The question is, how can you modify this so that it buffers all of the feature classes, not just shapefiles? You're going to have to replace the ends with condition with a list enumeration method. Pause the video now and try it on paper. In the first box we have our original script, which we said we needed to replace this f.endswith call and replace it with a call to list feature classes, in fact. So this, of course, needs to go outside. The listing of the feature classes needs to go outside of the loop. So what'll happen here is you get into each of the subdirectories or sub-workspaces, and that is set to the root. And then if you call list feature classes there, you're going to list the feature classes in the current workspace. If the current workspace is the name of a directory, which is a file geodatabase, for example, it will correctly list those feature classes in there, and it will still do our shapefile listing for us. Next, we'll discuss the built-in zip function. The zip function combines multiple lists or other types of sequences into a list of tuples. Here we have an example where we have a sequence that is a sequence of characters. A string is a sequence of characters. We have two sequences, one is A, one is B, and we say zip AB, and we come out with a list of tuples. So our list is the entire thing, our tuples are inside there, WAOWRODI. And you see how it pairs it up in the order of the items in the sequences. You don't have to use the same types in each of the sequences. So you can use two different sequence types, and you can also within each of the sequences use different types. So in this example, we're using a string, which is a sequence of characters, and a list. And the list contains all various different kinds of items in it. And it still zips it up. Apples is the first item in the list, and W is the first letter in the word, and W apples is the first tuple that comes out of this. And you can go on through and check that. O in word, and 6.2 is the next item in this list. It's a list inside of the list. And we go on down, we have a float, and we have a tuple. And we get R and the float, D and the tuple. You can combine any number of sequences. Here we're combining A, B, C, and D, just to show that we can do more than a pair. If the sequence lengths differ, the output uses the shorter length. So you can have different lengths of your sequences. In this example, we have a list of field names and a list of field types. And there are 3 field names and 4 field types. And you come out with a list of 3 tuples. You can use the zip function directly inside of loops in cases where you want to do something that combines a couple of lists. For example, you could be doing some kind of string formatting with 2 lists. In this example we have here, the cities are in a list and countries are in a list. We want to format the cities and countries in a fashion that lines them up together. We have 5 in the first list and 4 in the other, but because we know the shorter list is going to be the length of the resulting list, we'll only end up with 4 results. So see if you can predict what this loop is going to print. If you said, it would say city, Milan, country, Italy, city, Paris, country, France, city, Quebec, country, Canada, and city, Rio, country, Brazil. You're correct. Notice this is putting a tab in between the city name and the word country. Here's another slightly more complex example in which we're going to do a conditional statement because we want to check if a point is within a cube that is 1 by 1 by 1 and anchored at 0, 0, 0 and 1, 1, 1. The lists that we are given, now these are hard-coded here, but eventually we'll be reading data files in, so we might be reading 3 different columns, each of which contains a X or Y or Z value, and we can loop through those columns all at the same time so that we gather the points into tuples. We want to create a list of the points that are inside this cube, so we start with creating an empty list, and then we can zip the X, Y, and Z values, and we put some variables that make sense here because those are the X, Y, and Z values that are going to come out. Inside the loop, we're casting the X, Y, and Z values so that we can just use numerical values for the rest of the script. Notice that we're assigning 3 values at once, which you may not remember seeing before, but this is creating a tuple X, Y, and Z, and we can use those individual elements in our comparison statements to check if the point is inside of our cube. If it is inside the cube, we want to append it to our list that we created up here. If it's not, we're not doing anything with it, so we don't need an else branch. We don't need to have an else branch if the activity inside of the alternative is to do nothing. We're done. We print out our result. That's dedented back to the same level as a for loop. So if we had indented that to here, we'd be printing our points every time we'd be printing the list every time we add something to it. Rather than do that, we just want to print it out once when it's complete. So our results would look something like this. Notice in this print statement we have a carriage return, and that's why the resulting list of tuples is on the second line. So we found that 3 of the points are inside of the cube. Another slightly more complex example, we're trying to compute the areas of some triangles in square meters. And we have the dimensions of the triangles given as 2 distinct lists, one called bases and one called heights. The heights are in terms of meters and centimeters, and they're given with a semicolon and the letter M and CM after each one. Notice that we don't know how many digits are going to be in front of the M. We can't simply slice these and take the first thing off of there to get the number of meters. The bases are also given in meters, but they are given as numerical values. So we'll have to treat these 2 lists slightly differently, but we can still zip them so that we're going through the list at the same time, because the way it's given to us, the bases of triangles 1 through 5 are given in that order in the bases list, and the heights of triangles 1 through 5 are given in that order in the heights list. Those 2 lists, and we create variables called B and H in here. And the first thing that we want to do is get that height extracted because it's given as a string. We're going to get that height in terms of meters because we want to find square meters overall. So we're going to find the part of a meter that the centimeters are and add that on to the whole meter. We take the input H and we're taking out the centimeter letters in there just by replacing that with a empty string, and we do the same thing with the M that we have in the front. We know that there's a semicolon between the entry for meter and centimeters, so we can split the string in that way and know that what we have on either side of the split in the list, the first one will be meters and the second one will be centimeters. So we split that into 2 parts, and the first part we're casting to float. This is index 0 of the list, so that means that this is the meters, and we assign it to MH for meters height. Then we do the same thing with the centimeter part of it because that's the second part of the list. We cast it and store it, and then we set up the total value in meters by dividing the centimeters by 100 and adding that to the meters. And then on the next line we multiply the base times the height and take, because that gives you a rectangle, multiply that by half, and that's your area of a triangle. The base was already numeric, so we didn't have to do any of this manipulation to get it in that form. The last line we print out our results. It could be writing that to a file or doing some additional calculations based on the square meter area of a triangle.
We went over the list comprehensions, the built-in enumerate function, nested looping, zip function, and the os.walk function. And the next main topic is error handling.
This video discussed list comprehensions, an efficient way to generate a list based on an existing list. The enumerate method, which allows you to loop through a sequence and get not only the value but also the index as you're going through it. Nested looping for hierarchical relationships in data. The built-in zip function, which allows you to combine multiple sequences and iterate through them at the same time. And os.walk, which allows you to loop through directories and subdirectories within a workspace so that you can have a hierarchical data structure. And the nested looping helped us to get ready for the os.walk because you loop through the root and then you can loop through the files within the directories. The next topic that we will discuss is error handling.